So welcome to the gas turbine webinar today. We're going to be focusing more on the NAFTA market than we are the world market today, but we will be looking at the gas turbine opportunities for all the different parts of the world. And so we're first going to look at the markets, then take Duke Power as an example, and then talk about routes to market and a 5-step program to reach those markets. So there is a $180 billion market for combust flow and treat for gas turbines. The gas turbine owners will spend $180 billion per year for hardware, consumables, instrumentation, and services on an annual basis over the next 10 years. The industry capacity will only be growing at 3% per year. However, there will be upgrades to improve efficiency and meet environmental regulations. Plus, of course, we've got the replacement of catalysts, valves, pumps, and hardware, which bring expenditures for outside services and hardware to the $180 billion a year. Some of our key findings are that gas turbine capacity will grow faster than coal capacity, but installed coal capacity will continue to exceed that of gas. Solar and wind capacity will grow faster than gas, but will account for a minority share of world generation capacity. New materials and components can be acquired to improve plant efficiency, reduce costs, and even in a frequent cycling environment where flow-accelerated corrosion and other challenges are encountered. A number of simple cycle plants will be upgraded with a steam cycle. Zero liquid discharge wastewater systems are being employed where water is scarce, but also where discharge emission limits are stringent and owners are in a hurry to get their permits approved. Municipal wastewater will be increasingly used as a water source. The valve and pump opportunity at existing plants, when including both replacement and repairs, will be 6 times greater than the new plant capacity. Obviously, there are similar statistics for SCR catalysts and for urea and ammonia. Problems such as encountered with desuperheaters will require substantial investment. Costs of new SCR and replacement catalysts will be significant. Third-party O&M of gas turbine power plants will accelerate based on low cost of sensors, wireless transmitters, and improving value of data analytics. The largest power plant owners and third-party operators will account for most of the purchasers. In other words, not only for new, but for existing, they're pretty much the same players. Let's look then at gas turbine capacity in 2018 and 2021. And so in 2021, the world capacity will be close to 1.9 million megawatts, and we'll be adding 221,000 megawatts over that 3-year period. The two areas where the most will be added would be NAFTA at 55,000 megawatts and East Asia. But note that NAFTA in 2021 will have 620,000 megawatts of installed gas turbine capacity, which will make it the largest region and certainly a good percentage of the total market. So it is interesting that this is one area where in power generation, there's more activity in NAFTA than other regions. And Asia, of course, right now, for those of you who are involved in catalysts and urea and so forth, is where most of the construction has been in the recent years. So NAFTA will be the leading purchaser. By 2030, EIA predicts that in the U.S., natural gas generation will increase to 42% of the total power, and coal generation will decrease to 16%. And natural gas will provide 34% of the nation's electricity in 1919. So there will be continuous acceleration of the percentage over the next 10 years or so. Nuclear power is going to be tailing off somewhat as well. One of the bigger growing areas is going to be gas measurement. So increasing the measurement and control at existing plants, expansion of course, coal-fired capacity, but expansion of gas turbine capacity, and the development of better instruments which justify replacing existing instruments or use where instruments were not previously used. Expansion of the regulatory requirements to measure stack emissions continuously. Expansion of the number of pollutants to be measured. Expansion of the rules to measure fence line and other ambient pollutants. This is going to be an increasing challenge, particularly at refineries. Improvements of combustion efficiency with better in-furnace gas measurements. The top 15 power companies will spend more than $750 million for gas measurement devices in 2022. So the market is expanding because of what we call WOM, which is the Wisdom Obtainable Market. There's a sea change in the obtainable gas turbine combust flow and treat market. Those companies leveraging the Industrial Internet of Wisdom, IIoT, to empower the Industrial Internet of Things will generate both higher revenues due to the higher margins per unit sale, but also increased market share. To the extent that the sales include edge computer software built upon product and process knowledge, the unit sales are also increased. Markets can be divided into 4 categories, including the 3 traditional ones and a new one created by the sea change in the business environment. TAM, or total available market, is the total market demand for a product or service. SAM, or serviceable available market, is the segment of TAM targeted by your products and services, which is within your geographical or asset reach. SOM, or serviceable obtainable market, is the portion of SAM that you can capture. WOM, or wisdom-based obtainable market, is the bigger opportunity created by a sea change in the route to market. And as you see with the pictorial over here, what we're adding, or the product suppliers are adding, is edge computer technology packages, which would create a big WOM market empowered by Turbine Wisdom. And we have some urea and catalyst related people on the phone here. And so the examples there would be in a case where you're providing the urea and ammonia, that you're actually measuring the consumption of urea continuously, the amount that is in storage, and you also are then able to deliver the additional urea or ammonia based on that information, but also to be monitoring on 24/7 basis the use of that product and the impact on the NOx removal, which is what the achievement is to be, and of course the ammonia slip. And the same thing would be with the catalyst suppliers, that you're able to monitor catalyst activity on a continuing basis, and if the client is operating in such a manner as to damage the catalyst, you will be able to instruct them on what to do to solve that problem. So what are these data analytics? The argument to be made for the edge analytics rather than the cloud analytics is mainly that it gives the opportunity for the product supplier to impart his wisdom into the operation of his catalyst or his urea delivery or other components. But it also has the more general advantages of reducing network burden and connectivity costs, reduced data storage, reduces analytics latency. In other words, if it's done right at the edge computer, it's done in real time. Improves data privacy. The less that goes out over the cloud, the less risk there is. Improves connection reliability and improves scalability. And it can be applied, of course, to all the products that we were just talking about here. There are a number of services and software that is available. I think several of you on the phone know Scott Affelt. He runs Exemplar. He just made a presentation on this in our coal-fired boiler webinar a couple of weeks ago. But he and a number of other people are there to, and a number of software and hardware suppliers are there to help with the design of these edge computer systems. So let's get into an example of Duke. So Duke has a number of gas turbines along with their fossil plants and renewables. And they are heavily into the remote O&M and all the automation. And they point out that there's really a progression from reactive maintenance to preventive maintenance to predictive condition-based maintenance, and then proactive, where you combine all of the above and root cause failure analysis. The addition of smart monitors and diagnostics can be applied in a number of ways in your gas turbine systems. So there, certainly the monitoring of all these different things, from dissolved gas analysis to oil quality, pressure, flow, temperature, etc., all can be monitored and the data captured and just better decisions made because of it. Duke certainly, like many of the other utilities, sees a whole progression from monitoring to control to optimization, and then what they call autonomy, where you've got self-diagnosis and service, autonomous asset operations, self-coordination of operation with other assets and systems. But I might add there the what needs to be embedded in this, though, is the subject matter ultra expertise of the product suppliers who would also be monitoring these systems. We are undertaking the analysis of every major power plant system in the world with the realization that when you start monitoring all the equipment in a system, you're able to make decisions relative purchase at a corporate level. So whether it's Duke Power or National Thermal Power in India or Shanghai Godian in China, more and more of the decisions are going to be made at the corporate level, and therefore the marketing programs will have to be organized around each corporation. And in the case of Sinopec, for instance, in China, they have operations all over the world, and the same is true in many other industries. But so this is just an example of the kind of information on Duke on a general basis that we supply, as well as the specific information on each one of their gas turbine installations. But their revenues and their investment in new gas turbines and maintenance and things going forward, how much they're going to be spending on environmental, $37 billion 4-year in capital investment, and the amount that's going to be spent on their electric utilities versus the gas operations that they have as well. The fuel diversity, as we talked about, the nation going to more gas, so is Duke. They will be up to 35% of their power generation from gas by 2026. The investment again in environment. Note that on maintenance, they'll be spending $9 billion on maintenance over the next 4 years, or that 4-year period. So that is, I think, significant generally, that there's more money going to be spent on replace and repair of environmental as well as the power generation equipment. So we get into the details on each one of the systems and how much is going to be spent in Florida versus Indiana and versus their other plants as well. And how much they're going to be spending generally on environment. The air mats, for instance, the expenditures will be pretty modest going forward, 110 million over the next 3 or 4 years. So then let's talk about the route to market. Using the valves here as an example. So 10% of the existing valves will be replaced each year. So you've got 62 gigawatts of valves in NAFTA that are going to be replaced each year. So this is a significant number. Obviously, the same type of math applies to catalyst, where although the lifetime on the catalyst could be 7 or 8 years, and so it'd be, the ratios would be even slightly higher for the catalyst. So the top 10 100 gas turbine owners will spend $542 million per year for high performance valves. And we're defining the high performance valves. It's about half the valves in the system, and it's certainly every valve where the initial price is less important than the performance and life cycle costs. As any supplier to the gas turbine power plant market, you're going to be increasingly dealing with influencers other than the traditional ones that you've been involved with. When you get third parties that are operating multiple gas turbines for utilities, you have a whole new decision-making group. So how does a supplier interface with all these different groups? And so if you're looking at this chart over here, you've got the valve supplier or the catalyst supplier, or whatever, and it can be certainly dealing with, we just talked about, with a third-party O&M suppliers. Of course, the gas turbine suppliers in many cases are supplying the initial complete package, And then you have the automation suppliers that are increasingly taking a share of the pie. And then, of course, process providers. So somebody that would be providing a complete SCR system obviously would be involved in the initial catalyst production. But we have another couple of influencers, and one is the knowledge system provider. And we believe that there's going to be an increasing reliance on systems such as our gas turbine decisions that help power plants make better, lowest total cost of ownership decisions. But part of all that is subject matter experts. And we certainly see that the American experience on gas turbines is considerably greater than that elsewhere in the world, and particularly when it comes into the environmental aspects of it. And so we see the opportunity for the US-based companies to leverage the subject matter expertise for the rest of the world. And I think innovations is certainly one of the ways that companies will benefit most and stay ahead of the competition when you have a number of Chinese catalyst companies, for example, or people making urea that may not be the quality of the urea that's needed. One of the ways to distinguish and capture market share is to keep on innovating. And Cormatec, for example, is providing advanced catalyst and module designs, able to deliver increased catalytic potential, reduced pressure losses, reduced maintenance, and then to also integrate this single layer multi-pollutant catalyst, which can replace the two separate individual layers of SCR catalyst and CO oxidation catalyst. And there is a successful installation at Ennis Power. Another example of innovation, and I think how powerfully the innovation opportunity is surprisingly enough 3M, which is now remotely monitoring and replacing $22 furnace filters with use of a Bluetooth-enabled pressure sensor. This technology can even be better applied for gas turbine inlet filters. Filtrete smart air filters, which are billed as the first ever Bluetooth-enabled HVAC air filters for the home, are now integrated with Amazon Dash replenishment to automatically reorder air filters when they need replacing. In other words, the homeowner gets a package and he's got a new filter automatically. So Filtrete smart air filters are available for purchase on Amazon and retailers. So it's this type of technology that will allow the turbine owner to determine which cartridges need replacement, and certainly increasingly and improve operations in the increasingly critical task of minimizing particulate damage to turbine blades. So whether it's the cartridge manufacturer or the catalyst manufacturer or the urea manufacturer, there is the opportunity with the remote O&M to continually monitor and advise clients and to supply products as needed, and to actually share the reduced cost with the supplier if you can minimize the product use by guidance. the focus on on individual customers is kind of daunting. So you will need a business program to allow you to ease into this. And so it would be around these large corporate customers and certainly not around sales leads. This program can be implemented one customer at a time. If you start with the low-hanging fruit, the program can be self-supporting. So here are the details. Certainly the sea change we've been talking about, where the customer is going to be looking at high performance rather than initial price. And we see that happening in many organizations right now. They do have corporate-wide a ability now to run, to do total cost of ownership analyses. But the other trend is that a lot of these purchasers are merging and consolidating purchasing and selection decisions in central corporate operations. So the corporate staff is employing remote O&M and data analytics to determine the total cost of ownership for each product and each process. Now, I might add for some of you that it may be more difficult to be capturing the markets in the industrial section for gas turbines, but the large oil and gas companies are certainly taking, and refineries and some of the other industrial users are all taking this approach. So this one customer at a time is very valuable in dealing with a number of relatively small catalyst purchasers that would have many plants, and the total catalyst or urea purchase would be significant. And so the industrial internet of wisdom is needed really to empower the corporate staff and allow them to determine the lowest total cost of ownership. So the challenge is to persuade a knowledgeable corporate staff that the supplier's product has the lowest total cost of ownership for a specific process. This in turn requires knowledge of the customer's processes and a mechanism to convey this to the decision makers. So the progressive approach is one customer at a time, and the first challenge is to pick the customer based on size of the revenue potential, total cost of ownership advantages, sales experience with this customer, and then to organize the campaign, where you need to really coordinate the regional and corporate sales, engineering, and other personnel in the most effective manner. And secondly, to interface with the customer based on knowledge of his processes and valid total cost of ownership, which takes into account the site-specific factors for each plant. So the navigation tools that we can get into in a second step here, for instance, we have a whole system just for one utility, which is Berkshire Hathaway, which has a Nevada Power and Pacific Power and some of these others that do have the gas turbine systems. We do have the gas turbine reciprocating engine decisions, and we have whole decision guides on catalyst selection and on gas turbine inlet filters and continuing analysis. And we have a supplier program that has the details on all the plants and people. And then the 5-step business program, which allows you to progressively capture the low-hanging fruit and to make this transition cost effectively. At this point, I'm going to switch to a more detailed discussion of some of these things. Did anybody have any questions at this point before we move on to the second half here? If not, I will then end this show here, and we'll get out of this one, and we'll go to the other slide deck here that I wanted to show you. And that is one that we prepared a few months ago. So I'm going to skip through a lot of this information, but I think it gets a lot of the same sorts of information here, so I'm going to skip through that. But we go into some of these markets here, and the $100 billion market, but basically how much of it is in various different segments of the market, but how much of also is SCR systems, catalysts, reagents for SCR, pumps, valves, and all the other products that go into the new and replacement markets for the gas turbines. And what are some of the drivers? And there are things like the higher efficiency. So certainly for SCR, it's regulations in Europe and elsewhere. There's challenges with flow accelerated corrosion. There are seals questions. There's a lot of the more innovative water treatment technology like zero liquid discharge, etc. And then we talked about the regulatory drivers here as well. The gas turbine opportunities are, for valve companies, are certainly shaped by the IIoT. Same for these other products. And we talked about the inlet filters, but then the support program is what I want to get into here. We have the gas turbine supplier guide here, markets and guide, and it covers all these different areas here. And then we also have the decision systems. And the example, for instance, of the supplier alerts are what is going on in a particular period of time and who's acquiring who and what projects and things that there are. And then there's updates on the technology here and the updating the individual projects. So when the first entry date was, and then what the startup date and other determinations about each one of these projects. And then details on the gas turbine combined cycle plants in every country of the world. And then the analysis of the opportunities at the individual plants like Duke Energy that we were just talking about here, and some of the other even larger operators of gas turbines. And then we do get into the details at each plant. So in this particular case, we have who are the cooling water treatment suppliers and who is supplying the SCR was Peerless, which would be Seco duct burners from Cone. And then the CO catalyst, of course, from BASF here. So these are the kind of details that we have in the system as well. And we do track all the ZLD systems that are going into these gas turbine systems as well. And the new projects along with that. And I'm not going to spend much time on the software, but there is a lot of the software that is being applied to the gas turbine industry. And so these will be people that all the component suppliers will be interfacing with and will provide data that will be useful to them. And we did talk briefly about the third-party O&M, but this is going to be increasing, certainly with gas turbines as opposed to coal-fired plants where you might have a single gas turbine with 50 megawatts or something compared to multi-thousand megawatt coal-fired plant, you have much more of an incentive for the owner to turn to a third party to operate that for him. And so this trend is accelerating, and it is on an international basis as well, with the people like IHI having a whole flexible suite of O&M services. Mitsubishi Heavy, it's MHPS now, has operations remote control centers in both Orlando and in the Philippines. So NRG and several other utilities are actually providing digital process management and remote monitoring for client facilities in the region as well as for their own facilities. And the remote monitoring is becoming more of a standard practice for gas turbines. And of course, GE has been a leader in that with its Predix systems, and of course Siemens as well. But there are also people like Labrelec out of Belgium that is doing some pretty sophisticated remote monitoring and things as well. And Ethos is another example there. Of course, Siemens is monitoring more than 9,000 turbines, and GE is monitoring many thousands of turbines around the world. And Ansaldo has a system as well. I mentioned MHPS, but then you get into a lot of the component suppliers as well. So Parker has a whole condition monitoring system for gas turbines. And we did talk about the individual company opportunities to an extent. And I'm not going to get into the engine applications here, but I did want to show you one aspect of that. And of course, a number of you would be involved in the SCR for the engines. But one of the, and we do believe that the CHP is going to be certainly an attractive reason to install a large gas engine, possibly that rather than a turbine. And but I'm going to skip through some of this and just get to this greenhouse aspect here. So there's a huge initiative all over the world to use gas turbines and engines to not only provide the heat and power, but also the CO2 for the greenhouses. And if you can raise the parts per million of CO2 up to 400 parts per million, the growth goes up by 36%. So greenhouses all over the world are all using CO2 to add about 50% CO2 to the normal atmosphere. And all these plants have to be then find a source of CO2. And many of them are in areas where they also have to put in the SCR. So here is an H&H SCR system that reduces the NOx and delivers the CO2 to the greenhouse. And then the Berkshire Hathaway Energy that we mentioned earlier, they're growing 22 million pounds of tomatoes at one of their gas turbine plants, or the greenhouse owner is working with them, but at their plant using the CO2 from the BHE gas turbine facility. And Clark Energy is another company that's providing these sorts of packages. So that is another application that certainly is a potential one for the gas turbines. Alternatively, you've got biogas engines well, and some of the problems with them have been resolved in terms of cleaning up the biogas properly at relatively low cost. So that covers the last part of the discussion for today. Again, are there any questions that anyone might have before we close the session for today? If not, I'd like to thank everybody for joining me today, and we'll look forward to interfacing with you in the future. This is Bob McElvain signing off.